Hello, welcome to the third episode of the SEMgents. I uh, I thought today, or for this episode, we'd do something a little different, taking a look at kind of a thought experiment, somewhat. Um, kind of, not really a thought experiment, but I'm gonna talk about and introduce some cool topics that might apply to a specific problem and maybe something you might see in the field of psychology. If you look up any papers. Yeah, that's basically it. As in terms of updates. So yeah, I guess we can get started. So I hope everybody knows what the sport boxing is. It's a um, not full contact sport, but is or I guess it depends how you define full contact. There's much punching involved, and not really no kicking. Clenches are a thing, and you try to get the other opponent not to get up. And that's the basis of the sport. If you haven't heard of it, please come out from under your rock. Just, I, that's what I'm assuming. So boxers. I'm gonna preface this and put the question at the top, and then as we progress through, it might become more and more not revealing, but revealing is okay. It might the issue of the problem might be revealed a little bit. So I guess so. The problem that I decided to introduce is do boxers have markedly less do box I don't want that apostrophe, that's not supposed to be there. Do boxers have less problem solving abilities um, than um, than their demographic counterpart? That's basically what I'm trying to ask. I can't spell. It's also very, very, very demographic counterpart. And why do I say this? Well, that's what I'm going to get to throughout the episode today. Hopefully in an organized fashion. I do have like an itinerary and a list and things. So we'll throw this question at the. Hey, come on, give it to me. We'll throw this question up here. Okay. So, how am I planning to approach this question? Um, there are a few parts in the prefrontal cortex that are specifically involved with problem solving and kind of how to attack a problem. So if I were to just draw a rough, oh my god, a rough part of the brain. Let's just okay, just hope, just that's good enough. We have the frontal lobe here. We have the uh, kind of looking like that, I suppose. This section is the temporal lobe, parietal lobe, occipital lobe, and you have your cerebellum back here. You have your brainstem, medulla pons, all that good stuff for breathing and heart rate. So as the name suggests, the prefrontal cortex is a rather large section of the brain. It takes up oh man, my drawing is very off, but I'm pretty sure the frontal cortex is takes up a third of the brain. Oh man, my my brain architecture is a little bit off, but there is a big part of the brain called the prefrontal cortex, and most people know it for very you know analytical thinking and higher order thinking, and so we're gonna deconstruct that a little bit. There are two parts that I want to look at: the rostrolateral prefrontal cortex, and the dorsolateral prefrontal cortex. And I'm not gonna get into oh god, my F, bro. Why? I should be doing this at a better time, but you know what? I was feeling jazzy at some early hours in the day. I'll just explain how you can decode a lot of like heavy bio words about areas of the body. So rostral means head, means towards the head. Except when you're talking about the brain, it means towards the front of the brain. If you're talking about a person's body, so if I do this, rostral would mean this way. If you're looking at, let's say, like a cat or something, my cat is beautiful. Rostral is this way, because their brains are in line with the rest of their body. Our brains are kind of, so if this is the spine, and then we have our brain, it goes whoop, and this is how the body's axis looks like. It turns at the neural axis, if that makes sense. Neural axis. It's not maybe it's because I have my night retainers in. Neural axis. This is where it turns, and that's why it looks like this. So rostral means front, means towards the head. Dorsal means towards the back. Not towards the back as in like the tail. It means towards the back as in literally the back. So like this section right here. So it would mean up. Caudal is towards the tail. So this is caudal. Rostral means dorsal means towards the back. Kind of like if you speak some other Latin-based languages like French, dors, it means back in French. So that's how I remember it. And then you have ventral, which is towards the stomach. And that's the basis of brain cardinal signs. So rostral front, dorsal back, ventral stomach, caudal tail. They have there is another name for each four of those. There's there's anterior, which is the same thing as rostral. So there's anterior, there's superior, there's inferior, and then there's posterior. Posterior is easy to remember because posterior usually means the back of something. Anterior is the opposite of posterior in this case. And then superior, inferior are opposites, and it's easy to attach them to one axis. And so if posterior means tail, and it's not part of superior, inferior, you know that superior, inferior means back and stomach. And so superior means top. So when I look at a cat, what is on top? It's their back. So superior means the same thing as dorsal. And that's just how I navigate big ugly words in neuroscience. So let's just get rid of this ugly mess. Okay, so now we know where kind of these things are. So the rostral is the front part of the prefrontal cortex. Lateral just means towards the edge. You have lateral and then you have medial. Medial towards the midline. Lateral means towards the edges. So if I draw my person, lateral would mean towards the edge. So the hands are lateral towards the stomach. And then medial means towards the inside. So the groin is medial with respect to the feet. That's just and then there's a couple other ones, like you have things like contralateral, which means they cross over, but that's like, you know, when you talk about like, oh, the left hemisphere of the brain is contralateral to the body, so it controls the right side of the body, or it doesn't control, but it controls and feels and has a bunch of procedures for it. So okay, we have these two parts of the brain. Why are they important? So I'll start with the dorsolateral prefrontal cortex. So the DLPFC is responsible for. I'll include 2 articles in the description if you wanna kind of understand like where I'm coming from, and where I learned my information from class and where I'm coming to you again. The LPFC has been studied to and documented to process problem solving. So problem solving is not as simple as just doing math. It's taking multiple elements of a problem and combining them to create a solution. You can think of this as I'll just use the way they tested it in the study. They'd used a Tower of London. Tower of London is like a Tower of Hanoi. So if you've ever played the Tower of Hanoi, I'm pretty sure you have. Don't worry. It's the one where they have the 7 okay, this is supposed to be longer. 7 like increasingly larger donuts on the 3 pegs, and then you have to try and get the whole tower onto another peg. That's the basis of the Tower of Hanoi. Many people have played it just for fun, and if you haven't, there's a bunch of websites. You just Google play Tower of Hanoi or Bing or your preferred search engine. The Tower of London variant is there are still 3 pegs, except this time there are only 3 donuts. There's let's get some colors in here. Why not? If it'll let me. Let's try that. Okay, yeah. So there's a red one, there's a green one, and then there's a blue one. And the idea is that you have to try and get the pieces in a specific other orientation in a given number of moves. So let's say the researcher tells you to come up with this solution in 6 moves. Let's say, can you actually do it in 6 moves? 1, 2, 3, 4, 5, 6. No, I think you'd need 7 or 8. Yeah, see, problem solving. My dorsolateral prefrontal cortex probably took over in that attempt to explain this game. So you're taking multiple things and you're combining them into one solution. That's problem solving. It's like if you've ever done an escape room, or if you've ever tried to, I don't know, look at a piece of origami and then do it without knowing the instructions. I think that's not a particularly valid way of describing it, but it serves my premise. And then we have the rostrolateral prefrontal cortex. I did it this way because problem solving for boxers is a little bit more important than what the rostrolateral prefrontal cortex is important for, which is relation integration. Now, Mr. Student Alex, what is relation integration? Well, viewer, relation integration is combining elements. Looking at a problem that doesn't require too many concrete elements in order to solve. It's a subversion of problem solving, I would say. A good example of this is oh man, I forgot her name. Raven, I think. Raven's matrices. I could have sworn her name is Raven. But it's a psychological test. I can give you an example. It's like if I have a circle with a line like this, and I have a circle with a line like this, I have a last box here that's empty, and then I have a box with a line like this. I have a box with a line like this. I have another empty bigger box, and then I have a triangle with a line going down. I have that same triangle, but the line is this way. I have another empty box. Relation integration, you take pieces, you take the elements beforehand, and you put them together in order to formulate a solution afterward. A good example of relation integration is a majority, I'd say at least 70% of math, and that includes calculus, that includes like the extent of math, algebra even, because there isn't problem solving involved. When you do math, you're doing a step-by-step process of figuring out a solution. That's not problem solving. You're taking what is there and you're manipulating how it is. Manipulating is a bad word. You're manipulating every instance of the solution. Problem solving is you go from 0 to the solution. So this is 0 to 100. This you can think of 1 plus 1 plus 1 plus 1 plus equals n. I know it's 4, okay? I know it's 4, but this serves my point because there could be any number of stuff here. We'll just do this plus 1 plus dot 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 plus 1 equals x, okay? And then we'll just call these equal. Relation integration is a step-by-step manipulation in order to reach your solution. Problem solving is a 0 to 100. It's not always going to be a click, but generally you've Rubik's cubed your way all the way to the solution. Rubik's cubes is a form of relation integration. However, speed cubing, which is a faster form of solving a Rubik's cube, I would argue is problem solving. So, what does this have to do with boxing? Well, boxers, they take a lot of damage to their prefrontal cortex, or to their brain especially, by getting hit so much. And even football players, rugby players, contact sports where the head is of vulnerability. Any contact sport that isn't, I don't know, I can't think of one right now. To be honest, lots of contact sports are. I just chose boxers because I like to box a lot. Not competitively, but for the sake of the question. You get punched in the head a lot. Dorsolateral prefrontal cortex is, if I were to draw my ugly brain one more time, it's up here, on the side. Rostrolateral prefrontal cortex, somewhere in the front. Then you have like your orbitofrontal cortex and stuff like that, but we're not getting to that. We want this one, and then we want this one. We'll just draw in some stuff, like some sulci, some gyri, make it pretty. These are the ones we're involved with. They are very, very close to the front of the brain, or they are the front of the brain. They are usually within impact range. I know a boxer is not usually going for those parts specifically. However, it's not good to neglect the fact that they do get hit sometimes, and they could be damaged with respect to being a coup as a concussion. So like the place where the brain hits. So if the skull was surrounding this, just pretend my skull is nice. The coup is when the brain knocks back and hits the edge. So it's when the brain, goes all the way past the cerebral spinal fluid and hits the pia mater, the pia mater. And then the pia mater has this layer, this subarachnoid layer in between it and the dura mater, and lots of fun stuff. But it's when the cushion for the brain is hit so hard that it hits the back. And the counter coup is when the brain recoils back onto the opposite side and hits the other side. And that's a big reason why concussions are really nasty, because the brain is getting hit. That, and because there's a bunch of other stuff that, like the nature of a concussion is the brain getting hit, and then you suffer a bunch of physiological and psychological reactions, and you probably need to sit out so your body can heal and repair itself, and hopefully you don't need. I don't recall ever hearing of concussions needing brain surgery, but I can't imagine it can't happen. And that is the issue that I wanted to bring up. Do you think boxers would have less problem solving or just problem analysis skills, or any contact sport individual? Would they have less problem analysis skills than their counterpart demographic? So if I did a matching study and I took Tom Brady's equivalent salesperson, I don't know, somebody who doesn't work in a contact sport, would the person that doesn't work in the contact sport have better problem analysis abilities? Now, obviously, this is not a perfect study. We can't control for things like whether Tom Brady actually does, problem solving games and brain training at home. Not brain training games. Brain training games are a lie. Don't buy into them. I will argue to the end of the earth that they are a lie. Just play some Sudoku if you really want to go have fun with your brain. Or we can't control for things like the salesperson playing or brain training. We can't control for things like whether or not the salesperson has done other stuff that they don't tell us about. Anything with respect to the individual or personal characteristics that we can't control for, or that you don't know about in the matching process, can be a confounding variable. And so a big sample size is necessary for a study that might that might be like this. Finding an equivalent subject is usually hard for someone who plays contact sports. These guys are usually really strong, or their routine is particularly different in order to maybe change the variables or add some things that need be accounted for. However, I don't think it's out of the scope of a lab or study to do. I just thought it was a cool thing to think about. Does the type of activity that you do daily actually affect the way that you are psychometrically analyzed? And so most people would say, obviously, if you get slapped every day, that might change the way you're biased towards certain things. But I still think it's worth noting that this is a little bit more complex than getting slapped in the face. But thank you very much for joining me, and I hope you guys have a nice day, and I look forward to talking to you guys on the next one. Bye.